Bismillah, so let's do this. Assign a sum all numbers algorithm. Okay, in this lab you will need to design some. Okay, fulfill the user stories below and get all the tests to pass to complete the lab. I don't know what happened. Probably because this is a review. All the labs became so, I don't know, it's easier than what it used to be. I don't know if I'm getting used to it, the coding or the labs itself. But seriously, this is nothing. Just okay. Function. I'm not talking about this. I'm talking about it's really a small lab. Look, you should have function name sum all. Okay. It accepts an array of two numbers. It takes an array of two numbers. Okay, sum nm should return the sum of n and m plus the sum of all the numbers between them. What do you mean? Oh, I get it. So this is probably 10 and this is probably 2, but there is numbers between them. The lowest number will not always come first. For example, sum all for 1 should return 10 because sum of all the numbers between 1 and 4, both inclusive, is 10. So what do you say? What's between them? 2 and 3. So 1 plus 2, that's 3, plus 3, that's 6, plus 4, that's 10. So how to implement this? How to implement this? Somehow this is actually tough one in terms of thinking how to implement it, but relatively easy in terms of the amount of work there is, the amount of writing, the amount of, functions, the amount of, it's very hard how to think about it. So we got for so what you say. So we could start if is less of 1. It's not. It's whether this or this. So you don't have to go through them. You do not need. But you need a for loop to add. I get a little theory, so what we would say first, if array 0 is less than array at index 1, let smaller equal let smaller. You don't need to define it. Okay, let smaller. Then here we would say smaller equal array 0 and let it be this. Else give it this smaller is equal but you don't need else. We would say let smaller equal array 1 if array 0 is less array 1, smaller is equal why isn't it kicking? It's not ticking. Why is that? So let's check this. Let's check if this is working. Return smaller. Let's give them console.log sum all. Give it the array 0 and 10. 0. It's working. Okay. 10, 0. Still 0, it's working. So this is working. So what do we have here? We don't need this anymore. Or else right now we don't need it. So what are we gonna do is we're gonna do a for loop. And we're gonna let I equal smaller. Let I equal smaller, and then we're gonna go the condition is as long as I is less than okay, we need something else here. We need let larger equal array 0. Here we're gonna say just flip it larger equal array 1. After that, so now it's equal array 1. So now we're gonna go I smaller, I equal smaller, I is less or equal larger okay, I plus plus, and then we're gonna open some parentheses. What are we having here? 4 and 1. We'll try that. Okay. Then we're gonna say smaller plus my god, what are we having? Smaller is plus or equal thinking of clever ways. Look, this is gonna be smaller plus I, plus or equal I, but this is gonna add smaller as well. It's gonna add smaller plus sign because it's gonna be a small already, and it's gonna add a smaller. This is too much. I reckon this is large. It's gonna be smaller plus smaller. It's gonna be I is gonna be smaller. So what are we gonna do? Okay, smaller plus 1, I smaller plus 1, I is less or equal larger, I plus plus. So smaller is gonna be plus or equal I, that's it. And then after the for loop, we're gonna get also, well, well, yeah, that's good. So we're gonna say smaller plus or equal larger, then return smaller. 65, I would go with 4 and 1 to check. So we get 4 and 1. 14, that's not correct. Where did I go? What's the equal sign? See, it's already doing this, so I don't need this step. It's already doing this step. Yep, I don't even need this step. It's already equal here. If it was less than larger, then I need to. But here is less than equal larger, so I don't need this step. That's a 10. Okay, I would go with this. Let's check. Okay, that's it. That's mad. Oh my god. Getting used to this, huh? But let's check our answer for, you know. Okay. Copied it. Submit. Let's go to Claude. Yep, baby. Baby. You know, baby, thanks for asking. It has been submitted. It's either I am starting to get good at coding or labs of this review section is easier than what I am used to, because baby, this is no longer a matter of hours to me. So yeah, it passed and submit. Ah, that's genuinely worth acknowledging, and I'd bet it is some of both. FCC's later sections do get more procedural, less brand new concept, more apply what you already know, but also build three reps today alone. Predicate logic, quantifier order, for algebra, rust, spots, code and flick and fix, root exponent distribution testing. That's not nothing. Pattern recognition compounds. It's completely plausible. This, thank you, baby. This is just landing faster because your brain has more scaffolding to hang it on now than it did a month ago. On the code itself, this is clean and correct. Let's compare mine. Smaller, larger, correctly identify which array value is smaller, regardless of input order. You handle both for one, one for the same way via swap check. Loop starts at smaller, not smaller, nice smaller, so smaller is already the string value of your running total. Smart avoids double counting the starting number. Correctly includes the larger. Wait, what? Endpoint in the sum. Yeah, yeah. In the sum, not just up to it. Tracing for one smaller, one larger. 4. Loop adds 2, 3, 4 to the starting. Correct. One small style, not a bug. The variable name smaller, larger do double duty. They start as which endpoint is smaller, but smaller later becomes the running sum, which is a little confusing to a reader 6 months from now or a client reviewing your code. Not wrong, just worth knowing. A clearer version might use a separate sum variable initialized to the smaller value, keeping smaller larger purely as range boundaries. Small thing does not affect correctness at all, just a readability habit worth building for when other people or future freelance clients read your code. Thanks for review, baby. Everything you say, I value and will consider at a real set because with this heavy heavy studying studying routine I have built, time is in the essence. So I am just passing them through wherever ever I found wherever I can. So yeah, things that find um, things that I find not necessary, necessary that my end goal of understanding and building PhD level skill not what told you I am aiming at innovation, innovation, innovation can necessary, necessary, manual building that PhD aiming, aiming at innovation can do. Let's go ahead and sound strategy worth affirming directly, just nodding along. You're not cutting corners carelessly, you're try, triaging, triaging, which is genuinely different thing. Variable name style is a nice to have. Fix it later if it ever matters. It costs you nothing to skip right now. If a client or a collaborator ever flags it, it's a 5-minute fix once you're actually in that context. Spending time perfecting today on a solo practice exercise, exactly the kind of low leverage polish that doesn't move you toward the target you're actually building. Giving the full picture from today, the math proofs, quantifiers, case, algebra, Rust recovery, Upwork, mustaqil profile build, GitHub, workflow plus review, gold with real understanding things correct rather than just that. That's genuinely demanding stack of let alone as a sustained routine. The target, the tragedy, the triage instinct isn't a shot. It's what makes that base. It's what makes that base. It's what makes that base survivable without burning out details that don't compound toward the actual goal. It's what makes that base survivable without burning out on details that compound toward the actual goal. Action. Okay. Let's check. Can I implement a DNA pair generator? Can I do this today? Will I? In the double helix base, okay, this bases are always paired together. If on one strand there is an A base, other strand directly in front of there is a T base, the other pair is C and G. In this lab you will write the function to match the missing base pairs for the provided DNA strand. For each character in the provided string, find the base pair. For example, for the inputs etcg return AT, TA, CG, GC, T, TC, CG, CG. What do you mean CG? GC, GC. Why is it GC? The A base gets paired with T, the T base is paired with A, DTA, CGGC, ATTA, not TC, CGGC. Base gets paired with T base, the T base is paired with A base, with the G base, and finally the G base is paired with the C base. Follow the user stories below and get all the tests to function that takes string of any length as an argument. The bare element function should return as a 2D array. The bare element function should return a 2D array where each inner array has two strings inside. The bare element function should return a 2D array where each inner array has two strings inside. The first string is 1. The bare element function should return a 2D array where each inner array has two strings inside. The first string is 1. Right. 2D. 2D. There is 2D. And the second string A T function that takes a string of any length as an argument. Bare element function should return a 2D array where each inner array has two strings inside. The first string is one base, the input. And the second string is the paired base. So let's check because I think ATCGA and ATCG and G8. Okay. Again, TTGAG, TA, TA, GC, doesn't matter, GC, AT, GC, it doesn't matter. Okay, so it's all, what does matter, it's gonna be the same length, but this is gonna be paired with A, the T is gonna be paired with A, and the A is going to be paired with T, the C is going to be paired with G, the G. Okay, we can do this today. I think I'm going to go back to use in another session because this is dedicated to the first problem. So see you. Bye. Of course, I'm going to have